So a sphere of radius r is made from material of density p. Cool. So as soon as I've got that sphere and radius, I'm already thinking that it's going to go m over v. The sphere is fully immersed. Okay, so that gives me an idea that it's directly under the water. So I already know some forces are going to be acting on it, and it's got a liquid density of rho L. All right. Which of the expressions gives the upthrust? So force of up is my question mark. That's what I want to be solving on this sphere. Right, so if I think, again, free body diagrams, it's getting more and more popular in exams. Get good at these. They're very, very helpful if you practice. So I've got my force that's going to be acting downwards. That's going to be my mg, or my force of my weight. And then if it's fully immersed, it's holding. Basically, it's in a state of equilibrium, not balance. We don't use that word. We use equilibrium. And if I'm in that state, well, then the force of upthrust is equal then to the weight that's going downwards. So then now we can say then that the force of weight is going to be equal then to my force of up. Here comes the mathsy part, because we're going to use this for our mass, because it's the density of the solution that is actually really, really important. That's why they've given you this, because it's going to be the surface area that we take up, or the volume, and the density of the solution. So I'm going to sub this in for my weight. So instead of mg, I'm just going to change colors for speed, is equal to F up. I'm actually going to use this expression. So rho v g. Someone else on the course, it's really good, she calls this veg in a way of remembering it for Edexcel. I like it. It sticks with me. Stuff like that is good. All right. So now I'm going to say 4/3 pi r cubed multiplied by rho, but this is the rho of the liquid multiplied by g is going to give me my force of my upthrust. Okay. And if I'm looking through here, 4/3 pi r cubed, bosh, it's going to be c. Bang. Okay.